friends, you're welcome to this physics class. And in this class, we're going to talk about a very interesting and important topic in physics called force. And friends, I want you to pay attention because I'm going to make it very clear and very easy for you to understand. Shall we begin now, guys? Let's go. The first thing I want to ask is, you see things moving, different objects, humans, animals, vehicles, tractors, horses, wheelbarrows moving. What causes them to move? Anything you see that moves, there's a reason why they move. The reason why they move is force. Once again, guys, what causes motion? Force. Simple. So now we know that objects move because force is put on them, applied on them. We need to tell ourselves, what is the simplest meaning for force? There are so many meanings in your physics textbooks. They are all correct, wonderful. But the easiest one I want us to take is force is a push or a pull. Whenever an object is pushed or pulled, it is force that is being put on it or applied on it. And it is that push or pull that will cause that object to start moving. Is that clear, everyone, guys? Now let's go to the next stage. The next stage is force formula. There's a particular formula for force. Very interesting and important in physics. That formula is this. Force is the multiplication of the mass of an object and the acceleration with which it moves. If you want to know this force applied on an object, find the mass of that object. It must be in kilogram, guys. If it's in gram, you must convert it. Then multiply that mass with the acceleration with which the object moves. And the unit of acceleration must be in meter per second squared. Okay? Now let's give example. Imagine a tennis ball of mass 0.5 kg. When hit with the bat, moves with an acceleration of 10 meters per second squared. Calculate the amount of force that was put on this ball at the map. You say force is equal to mass times acceleration. Remember, the mass is already in kilograms, so you don't have to change it. 0.5 means 1 over 2 kilogram times, what is acceleration? 10 meters. Per means divide the second squared. So how do we find the value of force? 2 here, 1, 2 here, 5. So we see that force is 1 times 5 is 5. That's the size of the force. What about the unit? kg is up, multiplied by meter up. So you have kilogram meter divided by 1, there's 1 here, 1 times second squared. So the unit for force is kilogram meter per second squared. One of the neater way to write this is 5 kilogram meter per second squared. That is the unit of force. Remember, I told you that force from the last calculation was 5 kilogram meter per second squared. But the SI unit for force is always Newton. When you write a unit, write it in small letter. Start with small letter. Or you put it in capital letter as abbreviation. This unit was in honor of great physicist Sir Isaac Newton, who did most of the work in motion and force. Don't say this is someone's name, you should start with capital letter. When you're writing his name, of course, you respect that as a proper noun. But here is a unit. Units always start with small letter, except the abbreviations in capital letter. What does that mean? 1 Newton is the same as 1 kilogram meter per second squared. There's another unit for force. I just want to remind you. It's called dyne. It's called what? Dyne. That one is the unit of force when force is expressed in, rather than kilogram, you write gram. Rather than meter, you write centimeter, then per second square. Here in Newton, it has to be kilogram meter per second square. But if it's going to be in dyne, it has to be gram centimeter per second square. Now for the last thing, if you want to know the size of force, you want to measure it, guys, you need an equipment called spring balance. In some textbooks, they will write this name as force meter. It's the same equipment. Some other books can even call it Newton meter. So the three names are the same. They are used to measure the size of force applied on an object. Spring balance, or force meter, or Newton meter. In our next class, guys, we're going to talk about effects of force, whether force is a scalar quantity or a vector quantity. We talk about balance and unbalanced forces, and we take examples to illustrate force formula. Use force right now to apply the like on this video, comment, and share. I will see you in next class. Adia, bye.